Welcome to Real Civil YouTube channel. In this video, we are going to see the design of RCC building. Basically, we are going to cover what is the difference between ordinary design and earthquake resistant design. Okay, here I have a building. I have modeled it. I have applied the loads and also analyzed the structure. Okay, now I want to design the beam for ordinary moment resisting frame as a ordinary moment resisting frame. So for that I will select the all the beams. Okay, now you have to go to design. As our structure is reinforced concrete, I will go to concrete frame design, and here there is a second option, view revise override. Basically here the first is view revise preference. Here you will see design code is IS 456 2000. Okay, where if you go in view revise overrides, in second item you will see framing type and it has written over ordinary. Okay, so if you click here you will get three options: ductile, ordinary and non-swing. Okay, so we'll keep here ordinary. Okay, and we will design our structure. So what happens when we select ordinary, then our structure will be designed as ordinary moment resisting frame. Means it will not be designed for or designed as an earthquake resistant structure. Basically, it will be designed using the code IS 456 2000 only. Okay. Now I will compare. I will go to another model which is similar to the first one. Okay. Now we will repeat the process. Here I will select the beams once again. Now in design, here I am going to select ductile. Okay, which is already there because I have created two files. So when I select here ductile, then my structure is designed using IS 456 2000, also using IS 13920 2016, which is ductile design and detailing of reinforced concrete structure subjected to seismic forces. Okay, when you keep it OMRF or ordinary, it will be designed using IS 456 2000 only. Okay, so this code is basically used for seismic resistant design or ductile design. So if I apply here the command, then you will see there is a difference in the design. Okay, start design check. So let's see what is the difference we are getting here, or is it same values for the reinforcement. Okay, now here you can see this is a special moment resisting frame, and here we have ordinary moment resisting frame. So I will just put this side by side so that we can compare. So here you can see most of the steel is same, but at some places, for example, in ordinary moment resisting frame, the center steel mid of the beam is 304 mm square, whereas here it is 488 mm square. Similarly, in the middle beam it is 287, whereas here it is 479 mm square. Okay, so you will find little increased steel this still is related to the longitudinal. Okay, but you will get most of the changes in shear reinforcement. Okay, we will see the shear reinforcement also. So here I will yes, display beam design, transverse rebar. Okay, or I will directly see the area. Sorry, display beam design info. Yes, here I will select the rebar. Here I will select shear reinforcement and I will apply. Okay, then this is a special moment resisting frame. Now in this OMRF, again we will see. Here you can see the shear reinforcement. I will check the plan view so it is easy to compare. Okay, so here you can see it is around 637.99. Okay, 637 to 660. Now if you go to special moment resisting frame, you can see there is much increase in shear reinforcement if you design your building according to special moment resisting frame. And this is because there is a different formula for calculation of the shear. That's why there is a big difference in the shear. In longitudinal reinforcement, the clauses are mostly related to minimum, maximum reinforcement and all those. But here for shear, there is a completely different formula is there. So because of that, the moment or the shear reinforcement is more here. Okay, so that's what I wanted to explain. If you design your structure as an ordinary, then it will be an ordinary moment resisting frame which will be designed using IS 456-2000 only. And if you select ductile option, then your building will become special moment resisting frame. That means it is designed according to earthquake resistance. Okay, so that is the difference between these two. So thank you. If you have any doubt, you can comment me. Thanks for watching the video.